I'm Paul Mueller. I'm from the Vatican Observatory. My field is history and philosophy of science.
I'm Chris Graney. I'm a professor of physics at Jefferson Community and Technical College in Louisville, Kentucky. My field is the history of astronomy.
It strikes me that we're sitting here in the Rare Books Library at Louisville. This is your home turf. It was kind of, I think, your idea that we come here to this library to do talk today. Why here?
So one of the things that I do is I work for the Rare Books collection in a small way, and we have a number of original works by various Catholic astronomers. Original works by Copernicus, by Galileo, people that we'll be talking about today, Pierre Gassendi, Augustin CAUCHY, and these works are all part of the William Marshall Bullitt collection of rare mathematics and astronomy.
One thing that we were hoping to talk about today is just some of the great and not so great Catholic scientists through history.
Yeah,
and
Catholic astronomers.
Catholic astronomers especially, and not just the great ones, but some of the ones who are kind of in the underbrush, if you will. This book you wrote a book about a Jesuit astronomer named RICCIOLI. I read your book, I loved it. I really enjoyed reading your book, so thank you for that. But I'm wondering if you could say a few words just about the main thrust of the book as far as you're concerned. If you're going to do a 30-second commercial for your book, what would it be?
I don't know, 30 seconds would be tough, but I can sort of tie in what we've, some of the people we've mentioned and sort of lead that into Riccioli. So Riccioli is a figure who lives at the time when there is a big scientific debate going on about the nature of the universe. In other words, is the universe centered around the Earth, which is, if you go out and look up, that's kind of what it looks like. That's why we have the words sunrise and sunset, because it looks like the sun is coming up in the east and it goes across the sky and it sets in the west and then it comes up in the east again. He's in the middle of that debate. He tries to look at reason and science alone and not based on authority. He argues that the reason compels us to believe that the Earth is at the center, that science compels us to believe that.
In some ways, this talks about a way science itself was changing at this time, prior to the time of folks like Galileo taking authority into account, authorities like Aristotle, authority like the Bible, or authority like the hierarchy of the Catholic Church. Taking those authorities into account, that counted as part of science. So the whole notion of setting aside all authority means Riccioli is looking towards the sort of new conception of science, one where you make a point of trying not to make your decisions based on authority. What I loved about your book was at the heart of it is this argument where you try and claim what was at issue in the time of Galileo and Riccioli was not a religion versus science argument, but in effect a science versus science argument and a religion versus religion argument. You're arguing that really, from the point of view of the science of the time, the Tychonic system, geoheliocentric system, Earth at the center, made more sense scientifically than Galileo's system. Okay, now we know. Now we know that it's right to put the sun at the center. The Earth goes around the sun. But the historical question is what made sense at the time. Galileo saw, with great insight, that the sun's at the center. But the question is, was he saying that in a way which was persuasive to other people? Should reasonable people have believed him? Should the church have believed him right away? In a sense, you're saying that, for a scientifically literate person at the time, for a careful observer, Galileo had not really quite made his case, and it made sense to believe something else. I'm putting words in your mouth. I'll let you describe it, but that's what I took away from your book in part.
Yeah, I think that an important person to keep in mind here is a person by the name of Tycho Brahe. Brahe was an extremely prominent astronomer. He was the person who had proposed this idea that planets circled the sun circled the Earth, and Brahe believed that this is what the evidence showed. The two arguments that Brahe gave were both correct. First of all, Brahe believed that on a rotating planet, different parts of the planet would rotate at different speeds. If you're at the equator, in a day, you travel all the way around the circumference of the Earth. So you go 25,000 miles of circumference in 24 hours. You're going 1,000 miles an hour. If you're at the North Pole, you go nowhere, okay, because that's what the Earth would be turning on. So Riccioli says there's a difference between the North Pole and the equator. And should we not see differences in how things behave at these two places? It turns out that is actually correct. There's an effect called the Coriolis effect that has to do with the trajectories of projectiles and things like that. It's the thing that's involved in weather patterns and hurricanes and making things rotate. He was right about this. There was many things about the physics he was wrong about, but he was right about that. The other thing is that he said, if you look up in the sky, stars appear to have a certain size to your eye. You look at this, it was what was called magnitude. Astronomers still measure things in terms of magnitude. Tycho said, look up and you see Saturn and you see a star, and they look kind of similar. In the old geocentric system, the stars are just past Saturn. So they look about the same, they're about the same distance away, they're about the same size. Okay, so heavenly bodies are sort of a consistent size. But if you take that star and make it as far away as it had to be in the Copernican system in order for us not to notice any motion of the Earth with respect to the star, so Earth's motion around the sun has to be negligible compared to the distance of the stars. So you put those stars a great distance away, and then in order to have that size that we see up there, they must be really huge. So then you've just gone and made all the stars into these giant bodies that are far larger than the sun or anything like that. And so, yes, I think that, generally if you go and kind of manufacture an entire new class of monstrously large bodies, scientists are going to have difficulty with that. And so the discussion gets complicated, but the telescope turns out not to help that situation any. And so, yeah, Tycho, these ideas, Riccioli builds on the ideas of Tycho Brahe. Brahe had good objections. And Brahe is the major astronomer of that era. If you believed that the Earth wasn't moving, you were agreeing with sort of this incredibly prominent astronomer.
What I learned from your book is that in some ways, figures in the Catholic Church were right to hesitate to believe Galileo when he claimed that the Earth moved and the sun stayed still at the center.
My objection to this would be to say figures in the Catholic Church. Figures in the astronomical community.
Scientists.
All sorts of people
Sure.
hesitated to adapt this idea. This is
It's
a
a
scientific investigation that is very difficult to figure out what is right. All kinds of people were trying to answer what turns out to be a really difficult problem.
So what intrigues me is you could say something like, the Catholic Church went with the best scientific consensus of the day to say, well, we don't think Galileo is right. Please God, I wish they would have left it there. Instead, they overreacted. They overreacted and put out an actual theological decree, a juridical decree, asserting what the truth of the matter had to be. So the Catholic Church just way overreacted for non-scientific reasons to a scientific claim Galileo was making. There's lots of things you can say about that. One thing I would say, a lesson from that, is the importance of the Church having a light touch with respect to science. The Church has no choice but to express its doctrines, its beliefs, its liturgy, in terms of the language of the day, which includes the language of science. Science informs our daily language. So you can't help but use the language of science to express what you believe about God, about theology. But then science changes. So if you're too wedded to a particular way of expressing a truth of your faith, and then the way of expressing it changes, you're stuck. You end up fighting science. You end up trying to make science not advance. And I think that's what happened in the case of Galileo.
Of course, an extremely significant Catholic astronomer is Nicholas Copernicus. He revives the heliocentric theory that says that the Earth is a planet that goes around the sun. So much goes along with the Copernican theory about how we see the world. For example, Copernicus says Earth goes around the sun, all right? In the old geocentric ideas of Ptolemy, or even the later ideas of Tycho Brahe, the Earth is at the center of the universe, things go around the Earth. Or if you're Tycho, the sun goes around the Earth and some stuff goes around the sun. But in Copernicus's theory, the Earth goes around the sun, as does Mercury and Venus and Mars and Jupiter and Saturn. And therefore, Earth and those objects have something in common. This then brings up the idea that, Earth is a planet. Well, the other thing that comes out of that is, the planets might be Earths. And you immediately get ideas such as, is there intelligent life living on them? And then, of course, there's intelligent life living on them. And you get ideas about change. It was thought that in the ancient ideas about the heavens is that they did not change. They were different than the Earth. If the Earth is a planet going around the sun and the other planets are like the Earth, then those things must change too. And so there's so much about how we think about the universe that hinges on essentially the Copernican system. So this guy who worked in Poland, mostly doing things that was not astronomy. Copernicus was a busy man who did all kinds of other stuff besides astronomy, but he came up with this theory and it's extremely influential.
If I understand correctly, many people used Copernicus's theory even if they didn't think it was physically correct, because it was so mathematically useful for predicting positions of the planets accurately. You had plenty of people who were willing to take the Copernican theory hypothetically as a calculation tool without necessarily accepting it as a description of reality.
Or you could say that they simply adopted the ideas of Tycho Brahe, which is the Copernican theory in all of its workings, just with the Earth postulated to be the thing that's not moving.
So there's another Catholic figure. He's a priest in the Order of the Minims named MARIN MERCENNE, contemporary with Galileo. And in fact, he was the main popularizer of Galileo in France. So Mercenne's based in Paris. He's buddies with Descartes. He's buddies with Gassendi. Mersenne is most famous for being a center of correspondence in an age before you had academic journals. How did knowledge get shared? Well, somehow you have people like Mersenne who everyone starts writing letters to him somehow, and he starts sharing letters with people. So it's, this guy says this, you should know about this. So he becomes a big center, a node of correspondence, a clearinghouse for information. So Mersenne just vomited words. He wrote so much. In 1634, he put out a book called Theological Questions. And it's just kind of this light, no one topic. He just kind of treats a bunch of different questions, some technical, some humane. And what tickles me is towards the end of the book, there's 3 consecutive questions. Questions 43, 44, 45. 44 and 45, Mersenne is paraphrasing books 1 and 2 of Galileo's famous dialogue, where Galileo is giving his arguments that the Earth moves. So here's Mersenne in 1634, after Galileo has been on his head his trial in Rome. Here's Mersenne, a priest in Paris, publishing Galileo's stuff, paraphrased form. I have a great fondness for Mersenne because he's one of the early heroes of scientific communication, because he popularized Galileo, and because he was, like many of the scientists we've been discussing, he was just a real proponent of being mathematical, methodical, empirical in your scientific work. Do the drudgery, basically.
So when you were talking about Mersenne, you mentioned Pierre Gassendi, another interesting figure, another Catholic.
And a priest.
And a priest. And he wrote, there's a copy here in the Bullet collection at the University of Louisville. It's the sort of thing a student would carry around, introductory exercises on astronomy. Interesting thing about it is he is living in the time when what the structure of the universe is being debated. And so he has material in his book from the Copernican system, from the system of Tycho Brahe, he has stuff from the old Ptolemy system. All of these things are present in this book. So another person of note in our litany of scientists. Another astronomer in the list of Catholic figures in science is this fellow named John of Sacrobosco. There's not that much known about him. He's typically reported as being a monk of the Augustinian order. He wrote a book published around 1220 or so, called The Sphere, basically meaning the sphere of the sky. And it was basically an astronomy primer, a basic textbook on what you need to know about astronomy. And this is a really influential book. It is used as a teaching tool, and then other people write commentaries on it where they add to the knowledge. It is sort of like the standard textbook in astronomy for a period that approaching 400 years. It just covers all the basics of what you can see in the sky and what stuff does. It's not extremely complicated. It's not real long, but it's very influential, and SACROBOSCO is worth making mention of as a significant Catholic astronomer.
There's an Italian Jesuit in the 19th century named ANGELO SECCHI, who's working at the Jesuits' Roman College. In around 1870, Italy starts seizing the property of the church as part of the process of the unification of Italy. In the period before that, ANGELO SECCHI's working at the Jesuits' Roman College, and in fact, he has an astronomical observatory on top of the Jesuits' Church of the Gesù. The church was intended to have a dome. They never had the money to make the dome, and then the neighbors wouldn't give permission. They didn't want to lose the sunshine. So they never made the dome, but it was strong enough that they made an astronomical observatory on top of the church, and that's where SECCHI worked for decades. And he is seen as being one of the fathers of modern astrophysics. Astronomy, the laws of the stars, the positions of the stars, is the science of where the stars are. Can you tell me where they will be? Astrophysics, you're asking a different question. What's going on inside the stars? What's the physics of the heavens? SECCHI is the first one of the first ones at least, to systematically make spectrums of the stars, many, many, many stars, to the point where he could start to categorize the stars. And he came up with a classification scheme of 4 different kinds of stars based on 4 different types of stellar spectra. I'm at the Vatican Observatory, as you know, And we had a recent fun discovery. We've long known when the observatory, from its refounding in 1891, participated in an international research collaborative called the Carte du Ciel, the Map of the Heavens Project. Many different observatories each had a slice of the sky and a special telescope to map bit by bit that part of this, that slice of the sky over the course of decades.
Photographically.
Photographically. So with glass plates about yay big, you get a negative. And in I live at Castel Gandolfo, the headquarters of the observatory. In our archives there are these thousands of these glass plates from the Carte du Ciel project. What's fun, and a little bit embarrassing in some ways, is nowadays, if you have a telescope, you have a CCD chip attached to it, and you get a nice automatically digitalized data. Back in the day, you had these photographic plates. Someone had to sit down and look at it millimeter by millimeter and record every little dot and swirl, which is incredibly tedious work. Who did that in the case of the Vatican Observatory? We have long known that they recruited 4 sisters, 4 nuns, to do this utterly tedious work. Only recently did our archivist, Father Sabino Maffeo, unearth their names. These 4 sisters from the Sisters of the Holy Child Mary, Sister Emilia Ponzoni, Sister Regina Colombo, Sister Concetta Finardi, and Sister Luigia Pancheri. It's been kind of a fun moment of almost humility for us to recover the fact that so much of the drudgery, the hard, tedious work of categorizing and systematizing the measurements, which is essential to science. I mean, these people, without these people, science doesn't go, was done by these, until now, nameless sisters.
A similar group, also of women, worked for Harvard Observatory and doing, again, the rough work. They often were called computers because they did the sort of thing, what we think of as a machine, a computer, thing that does number crunching, was done by people. If you're back in the 19th century and you said your observatory had a room full of computers, what you meant is it had a room full of people sitting there doing hard, difficult labor. Most of the people we've been talking about have been priests, nuns. Augustin CAUCHY is a guy who had a wife, 2 daughters, and he was a mathematical astronomer. Most of his work shows up in mathematics. He wrote something approaching 800 papers. CAUCHY was a guy who, depending on who you read about, who's writing about him, either was really obnoxious or was a real pillar of academic integrity, because he apparently stood up for what he believed in, even if it was going to cost him his job. But he was a really significant mathematician and what we call a mathematical astronomer, a person who developed the mathematical theories that are used in astronomy.
In the library here, are there any of CAUCHY's works?
Yes, some of CAUCHY's works are here in the William Marshall Bullitt collection at U of L. Unfortunately, for someone who's a mathematical astronomer in the 19th century, of the various things in the collection, most folks are going to look at these and just see lines and lines and lines of equations, But he was a very productive mathematician. But he was also sort of a social worker in his town. He reportedly gave most of his salary to the poor of the town he lived in. Some people, write of him as though he was just a really great guy, and other people wrote that he was a really arrogant mathematician, and he probably was both.
Catholic scientists. Sometimes there's this sense out there, this assumption that somehow the Catholic Church is opposed to science. To be honest, this drives me a bit crazy.
Does he work for the Vatican Observatory?
Yeah, right, okay. I'm got the home court thing here. But look, I mean, obviously, there are horrible events in history. The Catholic Church made a big mistake in the case of Galileo. Your book shows that in some ways, the Church was, for the moment, right in the science, but it horribly overreacted for non-scientific reasons against Galileo. Okay, the point I'm going for here is I think the Catholic perspective on science is we believe as Catholics that we are made in the image and likeness of God. And part of who God is reason, divine reason. So when we do science, we are imitating God. We are being divine. And when we do science, we are finding the truth. And God is the way, the truth, and the life. So doing science is a good thing. It's a path to the truth, and I think the Catholic Church affirms that, even though at times it struggled when the science seems to contradict what people think is true about the Bible.